Hello, Assalamu alaikum. At the time of my presentation, I would like to give thanks to our honorable teacher for giving great opportunity of such type of presentation. My presentation name is Generator, submitted to Rocky Chakma Lecturer Tripoli, University of Science and Technology. Submitted by Amirul Islam, ID number 190500702, registration now 947, batch 70, trimester 3rd, Department Tripoli, session May 2019, April 2020. Outlines of the generators, introduction, second, parts of the generator, and third, classification of generator, fourth, losses of generators. We can discuss this above. In figure, we can see a generator, how can convert energy. An electrical generator is a machine which converts mechanical energy into electrical energy. Two basic essential parts of electrical generators are: one is magnetic field and a conductor or conductors which can so move as to cut the flux. Consist of the generator we can see in figure: brush, conductor, frame or yoke, pole shoes, tail winding, shape, armature. Yoke. It produces mechanical support for the force and acts as a protecting cover for the whole machine. It carries the magnetic flux produced by the force. We can see in figure the frame of the yoke, pole shoes. They spread out the flux in the air gap and also being of large cross section, reduce the reluctance of the magnetic path. They support the exciting coil or field coil. We can see the frame in figure. Pole coil. When current is passed through this coil, they electromagnetize the force, which produce the necessary flux in cut by revolving armature conductors. We can see in figure pole coils. Armature core. It houses the armature conductors or coil and causes them to rotate the hence cut the magnetic flux of the field magnets. We can see figure the coil winding of the armature core. Its most important function is to provide a path of very low reluctance to the flux through the armature from N4 to S4. Commutator. The function of the commutator is to facilitate collects of current from the armature conductors. We can see commutator in figure is like brush and bearing. The brush whose function is to collect current from conductors and usually made of carbon. We can see in figure carbon brush and another figure is bearing. Classification of generators. Generators are usually classified according to the way in which they fields are excited. Separately excited generator, self-excited generator. Self-excited generator are classified shunt on, series on, compound on, and compound on generator classified short shunt compound, long shunt compound. In chart, losses of generators, copper losses, armature copper loss, field copper loss, loss due to brush contact resistance. In iron losses, we see hysteresis losses, eddy current loss. Mechanical losses. These losses is air friction losses and friction loss. In flowchart, we see armature copper loss. Armature current scare into armature resistance, where the loss contributes about 30 to 40% of full load losses. The armature copper loss is variable and depends upon the amount of loading of the machine. Field copper loss, field current scare and field resistance. In this case of shunt wounded field copper loss is practically constant. It contributes about 20 to 30% of the full load loss. Brush contact resistance also contributes to the copper losses. Generally, these losses include into armature copper loss. Mechanical losses consist of losses due to friction in bearing and commutator. Air friction loss of rotating armature also contributes to this. These losses are about 10 to 20% of the full load losses. ST loss, in addition to the losses ST start about, there may be a small losses present, which are called as ST losses or miscellaneous losses. These losses are difficult to count. They are usually due to inaccuracies in the designing and modeling of the machine. Most of the time, ST loss are assumed to be 1% of the full load loss. Thank you for your time to spend my presentation. I representing my presentation.